Here the question is, what type of defect will be produced when silver chloride is doped with cadmium chloride? The defect is impurity defect. This is a type of defect that occurs when foreign atoms or ions are incorporated into the crystal lattice of the material. This defect can significantly alter the properties of the material as well. They are of two types: substitutional impurity defect and interstitial impurity defect. And the impact of impurity defects are they are changing the electrical, mechanical and optical properties. These impurity defects involve the inclusion of the foreign atoms or ions into a crystal lattice, which can significantly impact the physical and chemical properties of the material. Now let's come to the OR question. What type of defect is shown by sodium chloride in stoichiometric defect? The defect is Schottky defect. A Schottky defect in sodium chloride occurs when an equal number of sodium and chloride ions are missing from their respective lattice sites, and they will create the vacancies. Both Na plus and Cl minus vacancies are created in equal number to maintain the charge neutrality. The removal of equal number of Na plus and Cl minus ions ensures that the overall charge balance of the crystal is preserved. The presence of Schottky defect results a decrease in the density of the crystal. It also affects the ionic conductivity as the vacancies allow ions to move more freely. The second one is the non-stoichiometric defect, that is the metal excess defect. A metal excess defect occurs when there is an excess of metal cations, especially Na plus cations in case of sodium chloride. And these ions are present in the crystal due to the presence of anionic vacancies. The anionic vacancies means the excess Na plus ions appears because some chloride ions are missing from the lattice. The excess Na plus ions compensate for the missing chloride ions to maintain the overall charge neutrality. Typically, the excess Na plus may be present as extra interstitial cations. The presence of excess metal ions can increase the density of the crystal and impact its electrical and optical properties. It can also create the color centers in the material.